I last presented here 2 years ago, and I opened with this slide, and I haven't made any changes. We're still insert today's date there. I think that's a theme that's been running through the first 2 days of this conference, that we really, after 6 years, we really should be further along than we are, and why aren't we? The other thing I've heard a lot of people implore is, can we, as an industry, please get our act together and start realizing the benefits and move this thing along? And I've heard that before as well. That would be great, but I have to say I'm not convinced that just imploring the industry to play nice and work together to do this will actually get us where we need to be when we need to be there. We've done, at BT, I'm part of EE that was recently acquired by BT. We've done some virtualization. We've had some experience with it. We've got our IMS is virtualized. The EPDG, which is the box that does the voice over Wi-Fi service, is virtualized. They're all in silos. Yeah. Everyone is different. A different virtualization software, different version of OpenStack, maybe different COTS. And the reason for that is, the vendor support, the commercials. There's always this tendency that you land in a silo. So those boxes or those silos work, but they certainly have not delivered the agility, the cost benefits, all those things that we were promised 6 years ago. So far, NFV has not delivered, I think, would be a fair assertion. So what's going to change? Well, I guess the thesis, this is supposed to be a keynote. My thesis is, I think 5G is the game changer. And certainly from my perspective, when I look forward at how the mobile core is going to evolve, I think it is definitely 5G that is going to be a catalyst for crystallizing the changes that we need to see. The reason for that is, if you look at the standards, certainly in the core area of how the standards are constructed, it's built around this notion of cloud native and the service-based architecture. If you want to do that, if you want to do the slicing, you will build a network that is cloud native and virtualized and so on. So there really is no choice if we want to have a true 5G network. And I think that is the driver, the catalyst that will move the industry along. But I want to go one step further and assert that 5G might be the catalyst, but it will be in other areas of the network that we'll see the benefits first. So 5G will drive this change, but certainly in our context, we're thinking actually it could be the 4G network that would really deliver a lot of business benefit if it were re-architected along those lines. So that's what I'm going to look into. First, a bit of a refresh. From the perspective of 3GPP, from the perspective of 3GPP, this is, if you ask them what does a 5G core network look like, they'll put up a picture something like this, which I guess several people in this room will know and love. I just want to point one thing out, and that's this thing called the service framework, which has emerged recently in the standardization activity. When 3GPP started putting this architecture together, they just had all these new network functions talking to each other over some kind of bus. And they took this notion from the IT world. But in IT, there is usually something called a message broker that sits on that bus and controls all the flows. But it was absent in the release 15 version of this architecture. In release 16, they've realized that they actually need that something in there. And it's called the service framework. And I want you to hold that thought because it'll re-emerge. The other thing, and Dave put up a slide along these lines earlier, so I won't go into it in too much detail, but you have these standard use cases for how you'd actually evolve from a 4G situation to a 5G situation in the RAN and the core. So you have the 3 or 3X version where you're using a 5G new radio base station. The master is the 4G, but you're using the 4G core. So it's essentially a 4G network with islands of 5G radio in it. Option 7 is the flip side of that, where instead of using a 4G core, you're using a 5G core. So you still have a predominantly 4G RAM with islands of 5G, but it's feeding a 5G core. And then there's 4 where you flip the RAN around. So you've got a predominantly 5G RAN and a 5G core, but with islands of 4G. That's the theory. When we've looked at this, we think this is the practice, considerably more complicated, because you will have not just either 4G or option 3 devices, option 7 devices. You'll have a whole population of different devices out there in the wild, particularly if option 3 comes first, devices have that, then option 7 comes, devices have that. You've still got to serve all the option 3 devices. So you have a very diverse population of devices, and the 4G EPC and the 5G next-gen core actually have to be one network with 2 faces, because there has to be a common bit, a common control plane that decides, if you're a device, which one of these things do you want to talk to? And that has to be a common thing. Then the Cloud RAN, where we're looking at virtualizing some aspects of how the base stations work, means that the baseband processing could move inwards, while the core processing is moving outwards and decentralizing. At some point they cross. And so that thing is common as well. So actually the situation here is a lot more complicated. So you can't just say this is the 5G bit and we're going to virtualize that. It's one network. And I would assert that if you have a cloud native bit of your network, it's really problematic in my world if that is behaving in a completely different way to the rest of the network. Just a word on complexity. If you put all that together, if you ask, what does your network look like? What is the architecture of your network? That's what 5G or the 3GPP folks will show you. That's the world that we've been used to, where you have boxes that do things like MME or gateway, and they're in sites, and they do stuff, and they fail over, and that's your architecture. Now there's this new bit, which I call the deployment architecture. That's all this stuff about VNF components and microservices in VNF components, in VNFs. They're deployed in containers or virtual machines, or containers in virtual machines, or the reverse, and so on. You have to have all of these views in a consistent way to describe your network. That is a considerably more complex picture than the one we've been used to. Multiples. Yeah? If you're trying to get all this right. If you're just thinking about things like failover and availability, you have to consider all of those views of the network, and they have to be consistent. A bit on how VNFs are evolving, because we talk about cloud native, and I've heard at this conference people say, well, cloud native means you put it in containers. In my world, that's not quite true, and this kind of illustrates it. Over on the left there, you had the physical network node that we know and love, like an MME. Software in some bespoke hardware. First phase of NFV then, decouple the hardware and put it on a thing called an NFVI. And this is where we are now, with all those dependencies. Somebody comes along with their piece of software and they say, look, only run on HP, and only run on OpenStack version X, and you have your silo. What we now see is 2 developments from that point. One is VNFs getting bigger, more functions being put into the VNF, because the VNF is the managed entity that you will see on the big screen in the operations room. We see things called a control plane VNF that is simultaneously an MME and an AMF in 5G. So the VNF is kind of expanding its scope. And that thing is the thing that's then orchestrated. It's instantiated and built and configured. That's the thing you deal with at a certain level of network operations. The other development is inside the VNF, it's being broken up into microservices. And typical architecture we see is tiers of microservices that do different things. There'll be a load balancing tier, then a protocol processing tier, then a storage tier. The storage may be external. So we see things happening inside the VNF. Put those together, say 2 years hence, that's what you'd want to deploy your that is the deployment architecture you want for your 5G cloud native core. That to me is cloud native. Because the notion here is that if you lose some of those microservices inside the VNF due to hardware failures down in the NFVI, the VNF continues operating. It just contracts a bit. So you have a completely different paradigm for how availability is created in the network now, due to that internal structure of the VNF. So that's what we are aiming at. That is to us cloud native, and that's what we want to build this 5G network on. This 5G network that is also a 4G network. Bit on silos. You know, the silos are a bad thing. That's what we've got so far. We don't like them. VNF on one flavor of NFVI, VNFs on a different flavor of NFVI. A lot of people at the conference here are saying, we want to get this thing in the middle, where the NFVI is common, the orchestration is common, and you can just spin up your VNFs and not worry about it. I'm not convinced. I think that's hard to get to, particularly with the orchestration. I think that there's a lot of utility. There's a sweet spot before we get to that middle thing there, and that's what I call network domain orchestration. So if we're building a core network, there's limited utility in having the orchestrator orchestrate other things outside the core network. All I'm really worried about is orchestrating that core network, making sure that I can auto-deploy VNFs, and importantly, auto-configure them. A lot of people talk about automation, and they're thinking about instantiation of the VNF. I think configuration as well, because that is the prize. If we can automate the configuration, you get rid of half of all your network errors. Putting all that together, and you get a picture like this. You have, now in your architecture layers, you have the NFVI at the bottom, which we all know and love. You know, that is. Etsy normally talks about three of these. It talks about the NFVI, the VNF layer, which is the one in the middle, I call network architecture. That's how what the VNFs do, how they talk to each other, how you build a network with them. And then you have the MANO at the top, which orchestrates them, stitches them together, and does the lifecycle management. From what I've said so far, you'll maybe appreciate there's actually another two layers. There's the internal architecture of the VNF, how the microservices are organized inside that VNF, how maybe they're orchestrated. So you have almost like another layer of virtualization. And then you have this thing called the service framework, which is about how the VNFs talk to each other. Because in the new cloud native world, if I have all these microservices, I need something, some guiding intelligence in the middle that is going to coordinate all of the messages between the VNFs in a large-scale infrastructure, like a mobile core. And if you want to think about how you achieve all these attributes of the network, like security and scalability and availability, distribution of load, how it reacts to overload, monitoring, probing, slicing, some part of how you achieve all those things is in each of those layers. So if I'm thinking about availability, how I achieve a 5 nines telco grade service, I've got to think about what is the availability of my NFVI. How might my internal microservices in my VNF react to a loss of a piece of hardware in the NFVI? How might I fail over to a different VNF? There's a part of that story in each of those layers, and it's true for security and all the other things as well. So when you're looking at how you build the network, you have to think all these layers and how they each feed into all those attributes. And there are some examples of the kinds of things that live in each of those layers. Now, my thesis is, that's all true for 5G, cloud native, wonderful, but I want to make it true for the 4G network as well. And actually, very likely, because I think, Dave, you mentioned that maybe option 7 is slipping out, and it's getting harder and harder, but we still want to build this network. It could be that the first incarnation is just 4G. And you're building that new network, then you effectively you can then turn on the next gen functionality as it becomes available. So in that way, 5G is the catalyst for doing all of this hard stuff and getting all of the benefits, but it's the wider 4G network that starts to see those benefits en masse first, is the thesis. So that's all the technical stuff. Now a bit about the money. without which nothing happens. We're doing all this to close this famous scissor curve, yeah, with the escalating costs and the not so escalating revenues. Close that up. It all relies on this notion of decoupling and commoditizing the hardware, and potentially the software. Yeah, that was the original NFV promise. You break apart the software and hardware, you create a commoditized market in each. But our experience has been, and I think it's been reflected by a lot of people, is that when you decouple stuff, you've got to pay to recouple it. That's what integration costs are. So, and these costs could be huge. You know, validate, certify, support a VNF on COTS flavor X and hypervisor flavor Y is actually very expensive. And if you put a lot of your estate onto some version of an NFVI and then you want to change the NFVI, I've heard examples where the costs are horrendous. It would completely eradicate any savings you've made. And I call that recoupling cost because we've broken stuff apart and now we've actually got to pay to put it back together again. Also, and that leads to, effectively, what happens in our experience is you get semi-coupling, which is the worst of both. Yeah, you've broken it apart, but you've not really got the benefits of breaking it apart, and you've got to pay to put it back together again. So, for me, the industry, I mean, I've said we need to fix the problem if we're going to do 5G. The industry as a whole needs to find a solution for that reintegration cost. I've heard about the organization being the big barrier to moving forward. True, but at least as big is the unknown and unsolved problem of how we deal with the integration of all the components in the stack. Unsolved problem, it's got to be solved. Last point here is I've seen some what I call inappropriate software cost models from suppliers. What I call a VNF tax or a slicing tax. So the notion is that every VNF costs you money. And if you think about that, if I've got a network and I say, actually, I'd really like to slice this because that makes sense, it's isolation or it's a different architecture or have a different SLA, what you're really doing is optimizing the architecture because you could still have the same services on one network. It's suboptimal, but you could still do it. We've been doing it for decades. So I optimize the architecture by slicing twice the number of VNFs. If I'm paying per VNF, I've just increased my cost an awful lot. So some suppliers' software models, VNF software models, disincentivize the use of the benefits of NFV. And we're really making this a consistent message to our suppliers that we don't want to see slicing taxes and VNF taxes. Finally then, I hope I've painted a optimistic picture, but I did think about putting this slide up because of the news today. We're all watching a hurricane, horrible hurricane in Florida, but I've gone with it anyway. We've got to go cloud native, which is a big change. We've actually then got to build 5G services on top of it. We've got to reorganize around all that. Then the hard bit, moving live subscribers and services across, which will take 2 to 3 years, and is always very expensive, both in terms of how much it costs and how much revenue you lose. And new supplier landscapes, new types of suppliers, new suppliers doing the old things. A perfect storm of change. While doing that, we've got to maintain our customer quality. We mustn't disrupt that. If, and I believe we can, do all that, then the prize is what we've been talking about at this conference for the past 6 years, and that is building a truly 21st century capable telco. And it does need proactive drive. This was for my higher management. I've shown this slide internally and said it needs that as well. Engagement from top management. That's my bit. I've got 22 seconds left for a question.